Good afternoon. It is Wednesday, October the 22nd, 2025 at 1:20 p.m. Eastern Daylight Time, and we are keeping a very close watch here on Tropical Storm Melissa with 50-mile-an-hour winds as it makes its crawl generally towards the west-northwest at only 1 to 2 miles per hour. So it's barely moving at this given time due to very weak steering currents, and anybody living in Jamaica, the western portion of Hispaniola, the eastern portion of Cuba, and even Nicaragua and Honduras need to be watching this system extremely carefully, as this could become a very strong hurricane in the next 4 to 5 days. So with that being said, here's a much closer zoomed in view on the mesofloater satellite imagery on Tropical Storm Melissa this afternoon, and Melissa is dealing with moderate to strong levels of westerly vertical wind shear at the present time. And one might even think that there's no shear at all, but that's because if you look at the upper level cirrus canopy here, we are seeing outflow in all quadrants of the system. You can clearly see it here in the upper levels where we have that milky white feathery cirrus, indicating that vertical wind shear is not very strong at that present level. But when we look underneath the hood, we can see these other filaments of cirrus clouds. This is what we call gunk in the atmosphere when we have filaments of cirrus going towards the west like this. And this gives us an idea that there is indeed strong vertical wind shear out of the west underneath this cirrus canopy that we are seeing. So right now, while it looks like Melissa is not dealing with vertical wind shear at all due to the vigorous deep convection that the system is dealing with right now, there is westerly shear underneath this outflow cirrus canopy ingesting into the inner core, or whatever inner core structure is trying to form. It is not faring too well at this present time. We could also see this too on the infrared satellite imagery, indicating vigorous deep convection that is continuing to the east of the low-level circulation, which is pretty much right in here somewhere. So there is definitely a tilt with height with the system. And vertical wind shear like this tends to make the system look very blobbier, not much convective banding features wrapping around the circulation like this, which indicates that the system is indeed dealing with a lot of vertical wind shear. Even so, again, we have this outflow in the uppermost parts of the atmosphere. So right now, as long as Melissa has a structure like this, it is not likely to undergo any type of strengthening in the short term, but this will change with time as we go beyond days 3, 4, and 5. We were very fortunate this morning that we got aircraft out into the system to better assess the intensity and structure of Tropical Storm Melissa. And we can see on their first fix through the system, pressures were 1,002 millibars. Their second fix, pressure's gone up a little bit to 1,003 millibars. And the last two fixes through the system had pressures at 1,004 millibars. So we have seen a gradual fill-in of the low-level circulation here with pressure rises very gradually over the last 4 passes through the center on Melissa. It is also worth noting that Melissa continues to move generally off towards the west-northwest. Even so, it is making its short-term motion here off towards the south of due west motion right now. And that's because the system is moving erratically given how strong the vertical wind shear is. This is very typical with sheared-like systems, where we have the mid-level circulation over here. At sometimes it pulls and tugs on the system, so therefore it tries to wrap it further south here. So this is why we are seeing really erratic storm motions at the moment right now. And we don't exactly know where this is going, but the rough estimation is still due west-northwest right now at around 2 to 3 miles per hour. We could also see that the Air Force mission did not find any stronger winds than their prior mission last night. As you can see here, there's a lot of yellow, indicating winds that are right around 45 to 50 knots, or about 50 to 55 miles per hour, which indicates that Melissa is not strengthening anymore right now and is in a steady state of gradual spin down or weakening of the system, but it will recover potentially quite significantly in a few days, where we will probably see likely inner core structure try to form much closer to the center. So with that being said, let's talk about the track forecast first, and then we'll be dialing in on the intensity forecast towards the second half of this video, because some of the models are very bullish at showing this becoming a major hurricane in about 4 to 5 days. So we will need to cover that in today's update. But let's first talk about the track forecast from the European model, looking at the 500 millibar geopotential height. So this is in the mid-levels of the atmosphere at 18,000 feet above the surface. And what we have here that has been constant in modeling recently is this deep layer ridge of high pressure that has developed here over the Lesser Antilles. We have another ridge of high pressure nosing in across Mexico and the western half of the Gulf here, with a trough of low pressure to the north moving across the eastern portion of the United States. And what is left behind here is that Melissa is encountering very weak steering currents. There's nothing to yank this northward at all because, for one thing, on the European model here, the system is not very deep at all, and you'll see that here on the modeling as we move forward. All right, so as we go over the next 33 to 48 hours here, the system, again, is being smushed and marooned between two ridges of high pressure here. So again, you get flow opposing this way around this dominant ridge of high pressure. Then you get another area of flow opposing in the opposite direction from the south. So what you end up seeing here is these two flows are canceling each other out. In other words, the system wants to go north, but the system wants to go south. So it really doesn't want to go anywhere because these two opposing flows are equally strong. Again, 30 knots here, 30 knots here. And what you end up getting is a net flow of no movement. And that is the big problem here that models have right now is which ridge is going to dominate. If this ridge becomes stronger and noses in further to the east quicker, then the system could get mired underneath this ridge and bend back to the west just south of Jamaica, which is what most of our ensemble model guidance indicates. But what you'll see here on the GFS model is that this ridge of high pressure here does not build in as quick to the north of Melissa, and therefore this trough of low pressure that you'll see will be able to capture Melissa nicely as it gets yanked out to the northeast. So we have two different scenarios here that are going to be in play. So as we go over the next 3 days, you can see this ridge again that is beginning to build northward of the system. Our trough has had time to leave the scene here, so that's really not going to allow the system to get tugged northward anymore. So the system now on the Euro is being felt by this deep layer subtropical ridge over the Gulf at this present time. If we go forward here over the next 4 to 5 days, you can see what ends up happening now that this trough here comes down into the deep south, helping to amplify this ridge here to the north of the system, helping Melissa move generally westward here. And the problem with this is if this system moves further west, it could get underneath more favorable conditions, which we'll discuss here in just a little bit. So as we go out to day 5 here, the system really moves slowly. It doesn't stall. It's moving west, but it is not moving very fast either. And this allows the system to develop more significantly into a more formidable hurricane. Because again, there's really nothing to pull this northward at all. Because again, we have this ridge here coming out across the Western Gulf. We have this another opposing ridge off to the east. And so again, this is being mired between these two air masses. And until a trough comes out of the north here, say from Indiana, and that looks to happen down the road at some time, that will allow Melissa to be able to get yanked northward and allow it to escape over the Bahamas beyond the 6-day period. But there is a lot of variability in the modeling on how that all evolves because of the timing of that trough coming down from Indiana into the southeast and the timing of which ridge will be more dominant, helping to usher the storm northward eventually. Looking at the GFS model, the operational 12Z output that just came in this morning, and we can see again, a very different solution happens here. And if we go back in time, I don't know why I'm out to day 4 on this plot, but as we go out to about 30 hours, actually, let's go to today, you can see, of course, players on the field. However, this ridge here is not as strong. Okay, it's not being felt on Melissa as strong as what this ridge is. Or wait, this ridge is a little more dominant. Sorry. This ridge is a little more dominant. This ridge is a little further to the west and a little weaker. And this trough is a little bit further to the south. So what ends up happening is that Melissa feels that pull a little bit to the north here, but not very significantly like we had in prior model runs. And you can see this is pretty slow. 3 days, okay? It hasn't moved very much in 3 days from down here all the way up to there. So it's crawling northward into the western portion of Hispaniola. But the timing of this ridge is too late. So therefore, Melissa gets to feel a little bit of a pull with some troughiness out here in the southwestern Atlantic. So what ends up happening here is that the system gets mired underneath that ridge briefly before another trough, the one that the European model is not showing, moves across Indiana over the Midwest and then exits the eastern seaboard, helping to yank the system generally off to the northeast. And you can see that here. It drifts very slowly, but then again, eventually gets pulled out to sea here because of that initial trough with another one behind it, helping to keep that move generally off towards the east-northeast. So we have a lot of uncertainty here in the forecast, and I'll just show you again. 144 hours out, we have a system over here over the southeastern Bahamas and the Turks and Caicos Islands. And then at the same time, we have a system down here in the southwestern portion of the Caribbean in about 6 days. So there is a lot of disagreement in about 6 days exactly where this is going to be. And again, it will really depend on how vertically coherent the circulation actually is, the vortex that is, with Melissa. If it is vertically tilted with height, which is what we're seeing right now with all the deep convection mainly weighted to the eastern side of the circulation, this seems very well illustrated on the European model. This is why the European model is continuously moving this generally to the northwest and has it stalling. And take note again, this is not vertically coherent at all, not vertically stacked, and it is very offset, with all of the moisture here being very much weighted off to the east of the system. So over Hispaniola, you'd be getting a lot of rain, a lot of wind with this system, versus with what I'm about to show you on the GFS shows something different. But what ends up happening is eventually, once a system gets mired underneath that subtropical ridge, the flow generally is off out of the east, northeast, and the northeast. The upper level flow is more aligned with the storm motion of direction. The vertical wind shear backs off pretty dramatically, and we can see that here as the moisture plot illustrates. A lot of green now circulating all the way around Melissa here, and that's why the European model has been continuously insisting that Melissa could undergo some very quick strengthening beyond about 5 or 6 days. Now, on the other end of the model guidance on the goalpost is the GFS model, indicating that the system is not vertically tilted at all. And that is why the GFS wants a stronger system and it wants it to go north. Again, a stronger system in this case will generally move to the north and out to the northeast because it's going to feel the upper level westerly flow aloft and not at the surface, of course, versus a shallower system that moves generally with the low-level trade wind flow and then allows it to bend back to the west before that turn eventually happens off to the northeast. So we can see that here on the GFS. Again, take note that the system is vertically aligned here. Not much tilt with the vortex. Lots of moisture here, and that is why the GFS indicates that the system will be continuously moving off to the northeast here into central portions there of Hispaniola and the Dominican Republic, which is a big outlier scenario. I still don't think this is going to happen given the current status right now with what Melissa is dealing with right now. So this is more likely an outlier scenario, but regardless, is eventually if it does try to get better aligned though, it could strengthen a little bit and stall and then move back out into the middle or out into the ocean here, southeast of the Bahamas into the Turks and Caicos before moving out to sea altogether. So now that we talked about the track guidance forecast on Melissa, let's talk about the intensity forecast because this is very, very important because again, a stronger system will move generally out towards the northeast, towards Hispaniola and out to sea quicker versus a shallower system that will spend a lot more time in the Caribbean. So when we take a look here at the 200 millibar upper level wind chart here, we can clearly see that vertical wind shear that is impacting the system that is preventing Melissa from strengthening at the moment. Because again, we have westerly winds here. We have winds that are doing pretty much like this. This is not very optimal for Melissa to be within the environment here to strengthen. But what's going to end up happening here later on in the period, beyond 60 hours, and it might take 3 days for this shear to fall apart here, because as you can still see, there is a little bit of vertical wind shear coming in out of the southwest. So after about 3 or 4 days, the vertical wind shear really backs off pretty dramatically, and we have a little bit of an anticyclone just to the west of the system. And so what that's going to help to do is you're going to end up seeing more vertical wind shear here out of the north, and our system is pretty much moving generally off in this direction. So vertical wind shear here decreases markedly at around day 3.5 to day 4, and we end up with very little to no vertical wind shear out to day 5. As you can see here, look at this. This is really concerning with that upper level flow radiating in all quadrants, indicating that vertical wind shear is pretty light. However, there might be a little bit of a restriction to the outflow to the northwestern side, again, due to this little bit of westerly flow in the upper parts of the atmosphere. But later down the road, though, that westerly vertical wind shear really continuously decreases, and we end up with a very strong Melissa here to the southwest of Jamaica and just to the northeast of Honduras and Nicaragua. You could even see it here on the shear vector forecast. Take note again that shear is generally again in this general direction. But what ends up happening is later down the road that the shear does decrease markedly, and we can see anticyclonic shear vectors surrounding the system, which indicates that shear is going to be less than 5 or 10 knots in about 5 to 6 days, allowing Melissa to quickly gain intensity. So now the big question really remains on everybody's mind that is extremely uncertain at this time is, what is the full ceiling potential with Tropical Storm Melissa going forward over the next 5 to 6 days? Here's a look at the HAVS-A model, which is a very awesome hurricane-specific model that is trained in hurricane simulation and forecasting. And so we're going to use this model and look at all of our reliable hurricane models in this intensity forecast update. And we can see this here on the HAVS-A first, that it does show in the next 54 hours here by Friday afternoon into the Friday evening timeframe that a inner core structure does try to get well established here. And we can see where Jamaica is here on the top right side of the screen. We have Hispaniola, the Haitian Peninsula here, directly to the north and the northeast of Melissa at this time. So when we go forward in time, we can see that the system does try to develop that inner core structure. So by the weekend here on the 25th of October, we have a bona fide hurricane here perhaps on Melissa with winds that are right around 75 to 80 miles an hour. But it gets much stronger than this, and this is a big concerning aspect to this. If this goes further west, it finds itself in a much more conducive environment with very light vertical wind shear. The system could get very strong very quickly, and that is what a lot of us here as forecasters are watching very closely. So as we go out to day 4 here, this is not fully in. The 12Z is currently still rendering on the HAVS-A right now, and we only have the first 96 hours in at the moment. And we can see very strong hurricane here with winds that are around major hurricane intensity. That is winds of 115 plus miles an hour and a central pressure of 940 millibars. But if we look at prior model runs, though, this has been even stronger, perhaps. So again, that ceiling that I've talked about here has made this much stronger, up to a Category 4 hurricane here with pressures that were down to 915 millibars. I mean, it's been all over the place here, and we have seen a gradual weakening trend here on the HAVS-A, which is good news, but not always the go-to model just because it's only one model that we're looking at here. But it is still illustrating a major hurricane here in about 4 days, which is something that we will need to pay very close attention since this is not going to be far to the south of Jamaica. As you can see here, some green colors indicate tropical storm force winds extend pretty far out from the center. So this is more of your average size hurricane. Now, looking at the TAFB model into reference here, again, it's kind of its brother model. I always call it the brother model because the TAFB is the sister, the TAFB is the brother. So they're both the same model, but are initialized at different times just by a little bit, giving us a range of possible outcomes. And we can see here in 72 hours, the system is a little weaker to begin with, but it really develops that inner core structure exceptionally fast. I mean, we go from barely seeing a hurricane here in 75 hours by Saturday morning to seeing something that is pretty ferocious by Saturday night here on the night of the 25th and the 26th of October. You can see that purple there indicating Category 1 force winds with the beige color, peach color indicating much stronger winds there with pressures that are down to 949. But it gets much stronger than this. And we have a few more frames to look at here out to 114. You can see that the system gets much stronger. Out to 4 days, we have a very intense hurricane with winds that are around 130 plus miles an hour. And then on this particular model, we even have this peaking intensity at a Category 5 hurricane with winds that are around 160 miles an hour with pressures that are down to 900. Yeah, that's 900 millibars sharp, almost into the sub 900s on this particular plot. If we look at the prior run, you can see it was a little weaker by a little bit, but then the prior run had it much stronger at 887 millibars. So again, this is showing you the realm of possible outcomes that Melissa could be dealing with here. Has a very high ceiling potential with very high upper ocean heat content, very light vertical wind shear as this moves potentially generally west of Jamaica, and it encounters more moisture and a better thermodynamic profile for strengthening. So that is what we will be monitoring closely here. Now, the HWRF model hasn't rendered that far in yet on its 12Z counterpart, only out to 3 days, but we can see a hurricane here much further to the northeast than what the HAVS-A and the HAVS-B is showing. And instead, we have a hurricane very close to the tip here of Jamaica and not far off the coast of the westernmost portion there of the Haitian peninsula of Hispaniola. All right, and if we look at the prior model run on this one, it was weaker. So it is actually stronger on this run, and it moves very, very slowly and gets very close to Jamaica in about 4.5 to 5 days, and it just drifts. This is not moving very fast at all, and it just sits here for a couple of days or so. This would be very, very bad for many locations here, especially to the east of the system where the heaviest rainfall would be most persistent with some very heavy rainfall over the easternmost portion of Jamaica. Now, one last model that I wanted to bring up in this video is the HMON model. This is a very different oblong model that is very, very interesting in itself. It doesn't even indicate that the system gets close at all to Jamaica, and it pretty much continues to drift generally west-northwestward. And it ends up pretty strong here and also quite broad here with a large hurricane wind field and very, very large tropical storm force wind field. So even so, if this is going to be small or not, there's going to be a lot of heavy rainfall and a lot of wind impacts potentially over Jamaica in about 3 to 5 days. So with that being said, what are my personal intensity predictions here on Tropical Storm Melissa over the next 5 to 7 days? Well, I'll tell you this right now. Because of the level of uncertainty that we are seeing that is unusually high just beyond 2 or 3 days, because we have a system that is stalling, that is moving very slowly, if that, the intensity forecast is very complicated because it will depend on the vertical tilt with our system. So in my personal opinion here on my intensity forecast, I am going to be just below the National Hurricane Centers. Not that the NHC is the most accurate out there. I'll be straight up honest with you guys. I'm going to be real. NHC is extremely reliable. The most reliable source that you could ever find out there on the internet, all right? But because of my personal opinion and uncertainties here that I'm looking at, my intensity forecast is going to be lower than the National Hurricane Centers. And I am bringing this to a high-end Category 2 hurricane with 110 mile per hour winds at peak. That's my peak intensity right now, is 110 miles an hour at day 5. So now let's take a look at the spaghetti plot, exactly where Tropical Storm Melissa will be headed over the next 5 to 7 days here in the central and northwestern Caribbean. Please do not use this map to make decisions, folks. Please seek official info because, again, of course, I'm not 100% accurate with my forecast. I try to be. We all try to be out there in the weather field, right? But there is not a straightforward forecast here, and there is a lot of room of variability and uncertainty that remains here in our modeling in such a way that some of the models still want this go extremely far to the west, say towards Nicaragua and Honduras, while the most eastern extreme forecast here wants us to go over the Haitian Peninsula into western Hispaniola in the Dominican Republic. That's a GFS, by the way. And so there is a lot of room of variability, and we do not know exactly where this is headed. This could go north, this can go right towards Jamaica, this can go just south of Jamaica and then around Jamaica and then out to the northeast eventually. We just don't know. Therefore, the latest National Hurricane Center advisory as of 2 p.m. Eastern Daylight Time highlights here that the storm is going to be moving very, very, very slow. Not fast at all, and is only moving to the west right now at 1 to 2 miles per hour. Man, that is very, very slow. Not in a hurry to move out of the way right now. And this is expected to move generally to the north at a very, very slow pace. All right. That's what the NHC is indicating before the turn happens to the west out to 4 to 5 days. And again, because of that, there's a lot of uncertainty out that far, whether or not. Will it look something like this? Will it turn like this? We just don't know right now because of how slow Melissa is going to be moving over the course of the next 5 days. But just so you know, there are tropical storm watches out for Jamaica and hurricane watches out for the western tip there of the Haitian Peninsula of Haiti in the Dominican Republic. Please take this seriously if you are under any kind of watch at the moment, as these conditions are possible with hurricane conditions possible and tropical storm conditions possible on Jamaica in about 4 to 5 days. But anyways, if you did find today's tropical weather outlook and discussion on Tropical Storm Melissa very helpful, detailed, informative, and life-saving, please don't forget to subscribe to the YouTube channel if you haven't already. We're close to 60,000 subscribers, should be there by the end of October. Please hit the like button. Please ring the bell notification icon to get daily tropical weather updates here on Melissa, including live streaming coverage on Melissa and future updates as well. Please leave a comment in the section below this video as well and share this with your family and friends on social media. As always, have a great rest of your Wednesday here on the 22nd of October, 2025. I'll be back with you more, maybe tonight, depending on how models evolve over the course of the next several hours on this system.